this video, we're going to talk about something known as the discriminant. Now, in the previous videos, we've been trying to sketch a single curve. And as I mentioned in the previous video, that in the future video, we're actually going to look at where that curve cuts the x-axis, because that was the last stage in sketching our parabola. We've already gone through the other stages. We discussed the shape of that curve, the turning point of that curve, and now we wanted to discuss where that curve cuts the x-axis. But before we do that, I need to introduce you to a concept known as the discriminant. Now, the discriminant of any quadratic expression is given by the big letter D, and it's defined as b squared minus 4ac. Right? It's defined as b squared minus 4ac. Now remember, any quadratic expression is written in the form of y is equal to ax squared plus bx plus c. Ax squared plus bx plus c. So the expression b squared minus 4ac is known as the discriminant. And you might actually recognize this expression because whenever you are solving a quadratic equation, you sometimes use the formula. If you don't want to complete the square or you don't want to factorize the quadratic expression, you sometimes use the formula x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. You sometimes use this formula whenever you're solving a quadratic equation that you cannot factorize and you don't want to complete the square. So you recognize this expression is underneath the square root. This expression is actually known as the discriminant of a quadratic expression. Whenever you have a quadratic expression, b squared minus 4ac is known as the discriminant. Now, what is the significance of the discriminant? The discriminant helps us in so many areas when we're dealing with quadratic equations, but in this particular video, we want to see how this expression is going to help us sketch our quadratic function, our parabola. Now, as I mentioned to you before, we have different types of parabolas. Some parabolas are not going to intersect the x-axis. Some parabolas are going to intersect the x-axis. Now, the discriminant is going to help us figure out whether our curve intersects the x-axis or it doesn't intersect the x-axis. If it doesn't intersect the x-axis, it will lie above or below the x-axis. So what are these rules? The general rule is that if the discriminant d is greater than 0, then the curve will intersect. The curve will intersect. So if we take our quadratic expression and we calculate the discriminant of that quadratic expression, and we see that our answer is a positive answer, which is greater than 0, then we can deduce that that curve is going to intersect the x-axis at two distinct points. Now, the second rule to note is that if the discriminant d is less than 0, then does not intersect. It does not intersect. The curve will not intersect the x-axis. Therefore, it will lie above the x-axis or it will lie below the x-axis, like the other curves we've seen. And finally, if the discriminant is 0, x-axis is, and you might have guessed it, is a tangent to the curve. The x-axis is a tangent to the curve. What do we mean? Well, if the x-axis is a tangent to the curve, it means that the curve will look something like this. It'll come here and then it'll go up. The curve will only touch the x-axis at a single point. And the same applies if the curve is going the other way around. It will work as well. It will touch at a single point and then it will go down. So these are the three basic rules that you need to know about the discriminant. So when we look at our previous example of the curve we were trying to sketch, the curve was y is equal to 2x squared minus 4x plus 4. So in this case, our discriminant d is equal to negative 4 squared minus 4 times 2 times 4. This is our discriminant. And here we can see that this is equal to negative 16, and that's less than 0. So because the discriminant of this curve, because the discriminant of this curve is negative 16, which is less than 0, we know that our curve is actually not going to touch the x-axis. Our curve is going to lie above or below. But because we deduced in the previous video that this curve is a smiley curve, it's smiling, it has a minimum point, what that means is it's going to lie above the x-axis. So the curve that we've been trying to sketch is actually going to look like this, where this one here is the minimum point that we deduced in the last video to be 1, 2, to be 1, 2. And that brings us to the end. This is how we sketch the curve y is equal to 2x squared minus 4x plus 4. Now, to get this point is quite simple, which is the intersection with the y-axis. You know that this curve, when it cuts the y-axis at this point, the x-coordinate is 0. So simply plug in the x-coordinate as 0 here and get your y-coordinate, and you're going to get your y-coordinate as 4. So this is the point 0, 4. And that's it. That's how you sketch the curve y is equal to 2x squared minus 4x plus 4. So we deduce the shape of the curve. It's a smiley curve. We deduce the turning point, which is the minimum point, which is 1, 2. We deduce that it doesn't cut the x-axis, so it lies above the x-axis, and it's like this. And yeah, we deduce where it cuts the y-axis. Some of you may ask, well, if it's smiling, then why does it necessarily have to be above the x-axis? Well, because it doesn't make sense for the curve to do this, isn't it? It doesn't make sense, because it will go on, and when it goes on, it will cut the x-axis. So that doesn't make sense. That's completely wrong. That's why it has to lie above. So anyways, that's the end of this video, and until next time.
Na, 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 na.